first, I would like to thank you, Mareile Kaufmann, and the whole team of Social Bridges for inviting me to share my reflections about predictive policing beyond tools. So I hope to take up there where you just ended, namely that it is a bidirectional thing that we're talking about today. So the other days of the conference, the lack of access to AI's ways of working was discussed as a challenge. And the intention of today's talk is to open parts up of that black box. I want to make us think twice about the digital technologies that are put to use and to shed light on the ways in which digital data sets, tools, and humans collaborate when they create new insights. And when I do this, I also want to point to a few challenges in the process of using big data and prediction algorithms. Note that I refrain from using the term AI because you will see that what we talk about is not only man-made, so for the artificial and the insights such tools provides can probably not necessarily always be considered intelligent. So when it comes to prediction algorithms, then I want to move beyond the warning about biased algorithms or data sets that we often hear. As we shall see, I'm a firm believer in bias, and there is no such thing as an unbiased algorithm. There's no such thing as the perfect digital data set. The question is rather, in what way do we reflect about and work with these biases and imperfections? In what way can we take account of the fact that humans, data sets, and tools influence each other in the making of analyses? I want to start out with more overarching questions that I think are necessary to ask when we want to understand the role that digital data, tools, and humans play, for example, in law enforcement. At the moment, the mainstream of studies in this field focuses on the ways in which digital technologies, or we may call them AI technologies, change criminal phenomena and modi operandi, meaning that we can find research on cyber grooming and black hat hacking and black markets online and so on, criminal activities. There are also studies on how we can use technologies to make law enforcement more efficient. It's also done with AI, and how we can regulate the use of technologies in law enforcement. I would say that's quite stereotypical. I see a necessity to ask more fundamental questions, and I formulated them broadly in order to make you think about the questions you would need to ask in your own work. So how do digital technologies like algorithms change our lifestyle? How do we share data? In which situations and why? Who has access to this data and under which conditions? What kinds of logics does the digital world embody? And to what extent is human decision-making, or how are different approaches to truth reflected in the design of digital analytic tools or AI? Or to ask the other way around, how does the use of digital technologies influence ideas of whatever it is we seek to analyze? For example, crime patterns in the case that I studied. We see the relevance of these questions in many different trends. And within my field, and I'm a criminologist, it starts approximately here. So there are tools that are used to support crime control. That's what I'm going to talk about today. Much has happened in the past year. Software packages for predictive analytics, and that's where AI starts, in my view, are more and more used in police work across many countries. It's good to give you maybe a bit of an orientation here. There are those that have gained much international attention, like Chicago's strategic subject list to predict gun violence. That's discontinued now, luckily. But there's also PredPol and Palantir in the US, Pre-Cubs in Europe, HunchLab, which is called something different now in Australia. But there are also smaller kinds of software to assist police in identifying hotspots areas and dispatching police officers. These things are automated by today. So policing tools also include new investigative technologies. For example, the chatbot Sweeties that we see down in the bottom that targets online sexual perpetrators to provide personal information about them. And later this year, I also want to study a different aspect in the way in which humans, digital data, and tools collaborate in the making of DNA evidence. Now, yet a different focus on machine learning and law enforcement is this one. Data sets and algorithms are also used for judicial decision-making or courtroom fact-finding, especially, and now please let that sink in for a moment, when they calculate how risky individuals are and what their likelihood for recidivism is. So for committing crime once again. For now, these algorithms mainly exist in the US, but machine learning in courtrooms, I'm pretty certain, will come to Europe. So why is there a trend towards using these tools for data analysis, for having AI used in these areas? So the patterns algorithms find reduce complexity and help with decision-making in quite complex cases, we can say. These patterns are the key to decipher insights that are hidden in enormous data sets that are very hard for us humans to kind of scan. The patterns algorithms find can easily be visualized. Don't underestimate that step. I don't know how many of you have already talked about the visualization of things and how things are visualized, but all of this is also a part of a machine, kind of. So they give form to knowledge, which makes it easy to act on these insights. Yeah, if we have an enormous data set and it visualizes something for us, makes it a lot easier to take decisions. And because they do all this, patterns much embody the spirit of efficient and effective law enforcement. And I'm pretty sure this sits at the heart, really, also of the use of the AI debate in law enforcement. So efficient and effective law enforcement, they are relief for overworked police institutions or things like that. So, but it can also have positive effects on the offender if we want to go there. So those who are at risk could potentially be warned. Such tools can be combined with preventive policing when people get the chance to turn their lives around. And there's a hope, and I say that there's a hope, that such tools can be less, there's a hope that algorithms could provide uniformity in policing and sentencing, and that they are less biased than people in Israel. So most of the above sounds as if such tools are an alternative to human reasoning. Is that so? That was how my study of this field started. I started looking into policing 4 years ago, into technology more like 10 years ago. So that was one of the first questions I asked myself, and that is the central question for today. So many of today's discussions on digital technologies or digital tools give us the impression that they do the work by themselves. And the argument then goes like this: will people be out of the loop in creating predictions? And then one of my interviewees said, well, someone needs to push that on button. Well, instead of claiming that either humans or tools do the work, I make a pretty straightforward first suggestion for today, namely that tools, humans, as well as the data that is part of the analysis, influence each other. And in line with Donna Haraway's work, I ask if we're all part of this, and if digital technologies and data won't just disappear in the future. They're going to be here to stay with us, right? How do we become with each other? And based on this idea of becoming, I have recently begun to explore life cycles as an analytical term. Life cycles show us how tools such as sensors and algorithms, but also data, can take an active role in predictions. And it allows us to think of their productive potential. It helps us to think in and through relations. And that is relations with those who design them, those who use them, the data sets they analyze, and so on. So the life cycle can give us analytic entry points to think the many relationships between humans, data, and tools. How are data and tools brought to life? How do digital data and tools live their own life and influence human life? And only when we know these entry points, I claim, I'm a strong empiricist. I like looking at stuff, right? So only when we know these entry points, we know how we can try to shape the life with digital data, with AI, that we want to achieve. Now, it may be helpful for you to take a closer look at what I could mean by the analytic of a data lifecycle. I also have used the lifecycle to explain algorithms. I chose to speak about data because that kind of shows you also how data in the process of programming AI is coming alive in a way. So let us pick a starting point of the life cycle and say that data analysis begins with ideas about what data actually are. Ruha Benjamin, who is working at Princeton on race, data and technology, already considers names as data. What lies in a name comes with a certain expectation or association. In the worst case, it comes with a prejudice. So imaginaries of what data are and how one can use them and how one can use them to influence others are part of data analysis. So when the police uses algorithms for predictions or AI for predictions, they also decide which exact aim the algorithm or the tool should cater to. And ideas and imaginaries about what the algorithms or what the tool's aim is and which data set works best to follow up on these aims are here very closely connected. Okay? Data that is being analyzed also has to be generated first. Yeah? How data are generated and by whom is connected, of course, to data imaginaries, what we think data actually are. But not everyone who generates data shares imaginaries that drive their later use. Some data are actually generated with the intention of a very specific usage. For example, the police has surveys with which they kind of determine the type of data that they want to use. Others are generated with a very different aim in mind, for example, my health record, but is then used at a later stage for something completely different. So here we're talking about data creep. So some data is made for the actual purpose, other data exists already out there in databases and is scraped at a later stage from the net. So how data are made can also influence quite a bit what they will be used for and how they will be reused. In predictive policing, for example, one would need data about crime. And already the analog form, and remember, it's analog forms that police officers fill out, not digital yet. So the analog form that police officers fill out determines what type of information is available for analysis. So the data set available for analysis is also dependent then on who registers that data. And I like asking my students how high the percentage of police officers is that registers 80% of all the crimes in Oslo. Now, I can only interact with Mareile here. I don't see anyone else. But I would say it's like, I give you the answer now, it's 20%. So my interview material is a little old by now, but one of my interviewees said it's 20% of all police officers that register 80% of the information that we find in police databases. Now think about how powerful that is, how powerful these 20% are in determining how this data is going to be analyzed by a tool later on. Let's move on to data storage. There is no data without data storage. And how data is stored, for how long, where, and in which institution, who gets access and not, also co-determines data use. And that is why it's actually quite important to discuss how data should be stored. At first, the question of data storage may seem a little bit irrelevant, but now think twice about it. Under Corona, we experienced that storing information about our patterns of movement can give people an enormous insight into our social lives, right? So that's exactly why the police actually have quite strict regulations about when data needs to be deleted and who is allowed to use them. We all know that the private sector doesn't necessarily have the same restrictions. Choosing or curating data is another part of the life cycle that is at the same time quite integrated with the steps that I explained before. We know about the preparatory data cleaning processes, I guess most of us, which can become quite intense because we want to clean data sets according to what the algorithm later is supposed to learn and find, right? It's the training data set we're talking about now. So we know about these cleaning processes and they are quite intense, as I said, and what counts as significant data. And according to which type of data analyses are they significant? All of these are human-made questions that influence how a machine is going to work at a later stage. So in predictive policing, for example, we find a broad spectrum of patterns that starts out with either really small and highly clean data sets that are chosen according to very specific theories. I don't know how far you guys go into predictive policing, you don't need to, but there's, for example, theories that say, oh, you always commit crime very close to your neighborhoods and so on. So in that sense, they are theory-driven data cleaning processes. At the other end of the spectrum, we have some tools that are actually trained on data sets which the developers themselves describe as greedy. They use data greedy approaches that almost don't clean at all, because their idea is to correlate everything with everything else, get whatever they can get their hands on, and then see what type of pattern the algorithm comes up with. Now, all of these steps I just talked about are what one would call maybe, or could call, the vision of data analysis. Visions are integrated in each of these steps, right? Humans integrate their visions in each of these steps. Some of these visions may be realized, others not. And just maybe as an anecdote of the things that some of the people who use these enormous data sets have said predicts well is, for example, the phases of the moon. They say we can use the phases of the moon to foresee where people commit crime. And I was asking, so what's going on there? Well, what's happening? Well, we have no explanation for this. We just see that there is a correlation, right? So that is what we're talking about. So another step here that needs our attention, and that's actually at the heart also of AI, is data processing. And we could say so much about this. I basically could, as I said, explain the whole life cycle of an algorithm to you too. Now, to some, the whole life cycle here is data processing. But what I'm referring to here is that moment data is used to train a tool and to be processed by a tool. And it's this is the moment where developers identify which sociological parameters are relevant for predicting crime. And these parameters are then translated from sociology, like I say it's neighborhood, and then I get my math buddy, and he says, okay, this neighborhood is going to be this mathematic variable in the algorithm that we're going to use later. So, and just to explain it a bit, maybe once we have the variable, we can kind of, and once we have set up the algorithm is going to look at the training data sets and then learn from these training data sets what is considered a pattern and what is not considered a pattern. And once we're done with that, we kind of have a trained algorithm that hopefully passes a beta test. So you can now imagine how important training data sets are, how important all these processes are that I just talked about, because all of these processes involve decisions about what it is that this algorithm or this AI tool in the end wants to find. Right? So this is why I make a strong case for data today. Now, what's quite surprising, and I also have this in my interview material, is that some of the people who worked with the sociological parameters, for example, said, I don't know how this guy translated into math, you know, but they're working on the same team. So there's not necessarily kind of this understanding, a common understanding of what they're actually looking for, because they're looking at it from two different lenses, let's say so. So we know that the data lifecycle won't stop with the output a tool produces, right? Data reuse is closely linked to data generation and imaginaries again. Maybe that's, you know, they're all hanging together. Maybe that's why we're talking about a cycle, but it's through data reuse that data sets are basically taken in part of out of their context and are made to creep. And this is why our colleagues famously say data is no subject to function creep, but the function of digital data is to creep. So we also have to remember that simply by reusing data for a new purpose, data are not suddenly stripped of the original context. So let's say we kind of suddenly start opening up health databases for doing COVID predictions or something like that, right? So this is pretty sensitive data, and by reusing it to kind of predict pandemics, it starts to creep into a whole new area, but it doesn't necessarily lose the kind of the sensitivity that it had in the beginning when it was originally registered. So in fact, data that are collected in very precarious situations, such as crimes or migration or something like that, are specifically imbued with their original context. And these last steps of the life cycle, the processing, the reusing, and then again, reimagining and regenerating data, is what one could call or refer to as the vocations of data analysis. So we speak about the point at which data are no longer integrating with the original vision of the owners, but they follow what I describe as, you know, vocations of new analysis. Yeah, they make their own vocations. Sometimes they surprise us and change the direction in which data analyses actually go. So I would say definitely based on my research in this field, AI can surprise us with decisions as well. So what is the point of working with all these life cycles and stuff? So the point is to sensitize you to the amount of work that goes into, for example, predictive tools. I want you to become aware of these different turns in the life cycle where humans, data, and tools interact and determine together in which direction the analysis will develop further. So in which direction our AI tool that we develop would go further. And that means we need to appreciate all these details that I've just talked about when working with big data and algorithms, not least in the police. I mean, the police is just one of so many areas that are relevant here. So we need to acknowledge not just the role that we play, but also the roles that databases, and tools play in this process. And as we all know, these turns can become quite decisive for the kind of knowledge that can be produced. So I'm coming to the end now. So many of the aspects I mentioned were part of data analysis long before it went digital, we could say. But with the rise of digitization, I think they change. And due to the professionalization of data analysis and its integration into so many different technologies, vocations and visions of data analysis are really difficult to retrace. You really need to sit next to the police officers to understand what it is, how this prediction in the end comes about. And the various life cycles of data tools and humans join in what Donna Haraway again would call a spiral dance. Now, a dance is maybe not the policey type of metaphor, but maybe that's why it will hopefully stick with you. Because what the spiral dance here expresses is that with all these life cycles intersecting, there is no closure. There is no final resolution or conclusion that can be reached about AI. Because it's constantly changing, yeah? Data analysis will remain productive within our lives and within the police. So we need to understand that's why I started out saying we need to understand how we become with data analysis, how we develop with data analysis, and how does the police become with data analysis. So I close with some questions that help us maybe, yeah, I know you guys are allowed to ask me questions too, but I'll ask you some questions as well. So with some of the guiding questions that can help us maybe guiding our analyses of data in the future. How do we keep an adequate scope for human expression in the realm of AI or data analyses? Which vocations and visions represent our aims and the police's aims in a meaningful fashion? And which forms of data analysis actually provide us with new perspectives? So I thank you very much.
It's our chance to thank you for such a fantastic, well-rounded, and so it fits so nicely with so many themes that have come up over the last few days. We have tons of questions. I have a few of my own, so I'm just going to jump straight in. So the first question is, should AI tools that are used in policing or courtrooms be explainable and transparent to the public?
Yes, they should, definitely. That is what I'm very strong in advocating. But we need to be very careful how this is done, because you may have noticed that certain big companies like Microsoft and others have started hijacking that whole field of fairness, accessibility, and transparency, which is curious, given that often it's these big companies that like to sit on the information that we actually need, right? So it's, I just want to say, be careful whom you're shaking hands with when you want to really kind of go and delve down. And I would say I have been now in many different contexts been asked, how are we going to do this in the future? And I would say it's a highly specified exercise to be able to develop ethical and societally sensible algorithms, dependent on the location in the city, dependent on the city, dependent on context. Thanks for the question.
Great. I like decisive answers. That's a good one. We have the next one, which is, we humans often have to make complex value trade-offs when we face difficult decisions, for example, about retribution versus rehabilitation in sentencing. Can machines help or hinder our ability to do that?
Also a wonderful question. I would say outsourcing is not a good idea, but that doesn't mean that you cannot start using machines. So that's what I mean. You are allowed to use machines, but then better be aware about how this machine comes to a decision. And I cannot tell you the name of many judges who sit and know how an algorithm functions. So, and I find especially when it comes to recidivism and these kinds of questions, it's extremely difficult to say, I have understood the ethics of the machine here, right? So in a positive way, we could say there is sometimes the option that a machine can show us a surprising part of an information or a surprising connection that we haven't seen before, and that is worth investigating. This is again a trade-off when it comes to kind of all the surveillance that sits behind the machine, right? Because in order to find these new connections, we also have an enormous surveillance apparatus that feeds into trying to find these new connections. So it's a give and take. I would say the positive thing is sometimes it can give us a bit of a direction, but sometimes this direction can be horribly wrong. And I know quite a few wonderful papers, for example, by Ahmad Musharraf, who has written about the way in which some profiling tools have much has been said about profiling.
Well, I want to just sort of follow that up, because we had a talk right at the beginning of our 3-day event in which, the question was whether we would get better, or maybe read it as less biased patterns, if we took the human outside of that data lifecycle. You pointed at many points where the human obviously has input in shaping in Can you hear me? Everything fine?
Now, if you stop the second when we take someone outside.
So the question was, though, that if you do this sort of data greedy approach that you talked about, we still need to be able to interpret that data. And he mentioned sort of the 50 shades of gray in radiography, and there might be something similar, that you talk about all those correlations, or you might have an interaction between factors. What will we do with that data if we don't really didn't have a hypothesis going in, if we didn't structure the data?
Absolutely, yeah. No, I couldn't agree more. And as I said, it already starts at the level of imaginaries. It's not even when the data is generated or when we have scraped that database. It's already starting at the point where, depending on what you want to work AI for, if it's military, if it's sentencing, you need to first understand how are these people thinking about information who fed this machine with information, because that is totally going to be perpetuated throughout the life cycle. Yes.
So I'm going to have to leave it there, but there are a couple more questions in the live chat. We have Sebastian Krugel, our last speaker, waiting in the wings, but I just want to thank you again, Mareile, for your fantastic talk. It was so great, because we're getting some really hardcore applications now after a lot of sort of theoretical, more abstract things. So it's really wonderful to end our session with these very, very focused ideas. So thanks for the food for thought, for this great work and important work that you are doing, integrating AI into our life in a way that will hopefully make for a fairer world. I wish you well, and hopefully our paths will meet sometime soon.